So last time we got introduced to the vernier scale, which had a least count of 0.1 millimeter. Let's improve upon it by using the micrometer screw gauge, which it works on a different principle. Its least count is zero point zero 0.01 millimeter in the usual design. So how does it work? Well, we have a ratchet which can be rotated, right? It can be rotated clockwise or anti-clockwise. What happens if we have a screwdriver like this and you rotate it clockwise, then the screw goes inside. How much it goes this way when you rotate it once, how much it goes inside when you rotate it once is called the pitch. And when it goes forward or backward, if you turn it anti-clockwise, it will come out. How much it goes forward or backward in one rotation is called the pitch. And when it goes forward, then how much it has gone forward, we can read off on this main scale, which is in millimeter, graduated millimeters, which is on this particular sleeve. Main scale has got a 0, which is fixed. The whole scale is fixed, the sleeve is fixed. And there's a spindle here, and the spindle is touching this particular anvil. This particular point is here when there's nothing placed between them. And at that time, there is a 0 on the circular scale. The circular scale has got some divisions, typically 100. The 0 of the circular coincides with the baseline. This is the baseline of the main scale. It coincides with that. And this particular line also is coinciding with the 0. That is the ideal situation. There is no 0 error. So let us start with the ideal situation. So the anvil and spindle are touching each other. The circular scale edge is exactly placed on the 0 of the main scale, and the 0 of the circular scale is coinciding with the baseline of the main scale. Now suppose you want to measure the diameter of a wire, then you turn the ratchet anti-clockwise a little bit to create space where you insert the wire, and then turn back the ratchet a little bit so that the wire is stuck between the anvil and the spindle. So how much the whole thimble has moved to the right is the actual diameter of the wire, right? The pitch of this particular screw gauge is 1 millimeter, but sometimes even 0.5 millimeter. So what is the least count? Suppose I say that the pitch is equal to 1 millimeter and the number of divisions on the circular scale is 100, right? So when you rotate it once, then suppose you rotate it clockwise, then it goes 1 millimeter to the left. Suppose you rotate it half, then it goes half a millimeter. And what is the meaning of half a rotation? Means only 50 divisions have been rotated. So the smallest rotation that you can detect with your normal eye is one division, rotation of the ratchet by one division, and that is a least count. How much is the value of one such division? 100 divisions moved means 1 millimeter. One division move means 1 upon 100, so 0.01. That is how it gives you such a good least count. So the least count of a screw gauge is a distance moved by it along the axis in rotating the circular scale by one division. Therefore, least count is pitch divided by the number of divisions on the circular scale. So let us see some examples. Circular scale has 100 divisions and the screw moves by 1 millimeter in one rotation. That is the usual design. Since it rotates 1 millimeter in one rotation, that is the pitch, 1 mm, and least count is pitch divided by the number of divisions on the circular scale, so 0.01. Suppose you have a different design. Circular scale has only 50 divisions and the screw moves by 1 millimeter in two rotations. 1 millimeter in two rotations means in one rotation it moves only 0.5 mm. That is the pitch, 0.5 mm. And the least count is pitch divided by the number of divisions. Well, it turns out to be the same as 0.01. But look, suppose we increase the number of divisions on the circular scale to 500 and the pitch is the same, then the least count becomes 0.5 divided by 500. So the least count of a screw gauge can be improved by increasing the number of divisions on the circular scale. The lower the least count, better it is, by the way. Okay. Now, zero error can occur. As I said earlier, if there's no zero error, then the zero of the vernier will be coinciding with the baseline of the main scale. But here it is not coinciding, it is behind. So the fifth one is coinciding. The fifth division is coinciding. So when you do an actual reading, then you're already ahead by 5 divisions. That is going to inflate your reading. That means your reading is going to be more than the actual. You have to subtract. This is a positive error. How much is the positive error? Let's assume the usual least count of 0.01 millimeter. So how much is the positive error? The amount of error is the distance by which the zero is offset from the baseline, and that is the fifth division, pth division has come here. The amount of error is the least count into p. Least count is 0.01 mm and p is 5, so 0.05 mm. In the second case, the zero is ahead from the baseline by again 5 divisions. So now it is a negative error and least count is the same. So negative error is there. The error is 0.05 mm with a negative sign. And as you know, the correct reading would be the observed reading minus the zero error with the sign. If it is a negative error, the correct length would be more than the observed length. If it is a positive error, then the correct length will be less than the observed or measured length. Clear? I hope it is. What is the reading of the screw gauge? The reading of the screw gauge will be just like vernier, main scale reading plus the circular scale reading in this case. Main scale reading is 2 mm. It is ahead of this. This mark is the 2 mm mark, right? It is ahead. How much ahead? Well, the 56th division is coinciding and the least count is the same, 0.01. So 56th division is coinciding. Therefore, the circular reading is the least count into P, where P is which division is coinciding of the circular scale, that is 56. Least count is 0.01, so the circular scale reading is 0.56 mm. The total reading is the main scale reading, that is 2 mm plus circular scale reading 2.56 millimeters. So that is the reading of the screw gauge in this case. There can be an error which is called backlash error. You're moving the ratchet clockwise, anti-clockwise many times, so there's a wear and tear of the threads of the screw. And because of that, on reversing the direction of the rotation of the thimble, the tip of the screw doesn't start moving immediately. You have rotated the ratchet by let us say 2 divisions, but this guy has not moved this way or that way. It is static because of the wear and tear of the threads of the screw. It remains stationary for a part of the rotation. This causes an error called backlash error. How to avoid? The screw should be rotated in one direction only. If it is still required to reverse the direction, do not change the direction at once. Move the screw a bit further, stop, and then rotate it in the reverse direction so that slipping. You know why it doesn't move even though you have rotated? Because it is slipping on the threads of the screw. So to avoid slipping, you adopt this method that you avoid going back and forth. You go only in one direction. But suppose you do have to reverse, then move it a bit further, stop, and then gently reverse. Then it won't slip. Otherwise, slippage will occur and you have a backlash. So this discussion with the vernier and micrometer screw gauge was about measurement of length. Let us learn about measurement of volume. How do you measure a volume? Well, there are certain things, certain shapes like cube, sphere, cylinder, cone, cuboid. We have a formula for the volume of those shapes. Suppose you want to measure the volume of a cube, then what do? You just measure each length. The volume of the cube is length cubed. Suppose you want to measure the volume of a sphere. Volume of a sphere is 4 by 3 pi r cubed. Just measure the diameter using whichever scale you have, vernier or micrometer. Just measure the diameter. So you have the radius and then you have the volume. Cylinder. pi r square h. Measure the height, measure the radius. Volume of a cone, 1 by 3 pi r square h. Measure the height of the cone and the radius of the base. And any cuboid, with cuboid means it is not a cube. The length, breadth, and height are different, so it is length into breadth into height. The point is to measure the volume of such shapes, you just measure some edges and then you have a formula. But what happens if you have an irregular object? Suppose a piece of stone, it is some odd shape. How do you measure the volume? Then we use the displacement method. You know that if you take a solid and put it in a liquid, suppose it sinks, the volume of the liquid that it will displace is equal to its own volume. Using this principle, we can measure the volume of that particular object. So we have instruments like burette. There's a burette here where there's a certain cross-section area, typically 1 square centimeter, and the total capacity of the burette is 100 milliliter. Now, what is milliliter, by the way? 1 milliliter is basically 1 cubic centimeter. And then there are graduations like 0 to 100. So suppose it is filled up till here, right? Then it will have a marking. You can read off how much is contained inside it, right? Then you have a measuring flask that has also got graduations depending on what level of liquid that is there. It comes in various denominations, 50, 100, 250. You have a measuring cylinder also, which is also graduated, something similar to the burette that has got different denominations. Then you have a pipette, which is 20 or 25. This pipette is shaped like this. Both edges, both ends are open. So you have only one mark on the pipette, and that will say, depending on the size and shape of the pipette, it will be either 20 or 25. This pipette, how do you fill it up? You put it inside the liquid, one end inside the liquid, and the other in your mouth, and suck so that the liquid rises, rises. When it rises above the mark, then you stop, and then immediately close it with your finger. Now the level is more than that mark, so you need to bring that level down. So you release your finger just a little bit so that the liquid comes out. And when the level has come down to that thing, then the amount of liquid in the pipette is exactly 20 or 25. These are the instruments that are used to measure the volume. Now, simple, suppose I want to measure the volume of this screw, right? I take a measuring cylinder, put some water in it, see the reading over here, right? This is the reading. And then I immerse this screw inside it. So it displaces a certain volume of the water equal to its own volume. So the level of water rises, and the difference of the two is the delta V, or volume of the particular thing. This can be used for an object that is heavier than water. You can even tie this object with a string and then lower it completely inside the water. The string itself should be thin, because if it is very thick, then it will displace some water by itself. That should happen. And ensure there is no parallax. Keep your eye here. Keep your eye here in level. And there's a meniscus, the shape of the water is not perfectly horizontal. That is due to a phenomenon called surface tension. So it will be like this. The meniscus shape will be something like this. So the reading is the bottom of the meniscus. Now you will say, what about this much? To that extent, there's an error. Okay. To that extent, there's an error. But that error would be much smaller than the volume of the solid in most cases. So it works fine with us. This is for an object heavier than water. What do you do for an object lighter than water? It won't sink inside. You've got to make it sink. So use a sinker first of all. We have a sinker over here. We lower it with a string, and we have read the reading of the water over here in the measuring cylinder. Right. Then whichever object whose volume we want to measure, say a cork. This is the cork. Then next time we tie the cork with a string and again lower it. Now it won't come up because it is tied to the string and the string is having a heavy object sinker, so it will go inside and the level of water goes up from 60 to 70, and this is milliliters, right? Therefore, the volume of the cork becomes 70 minus 60, 10 milliliters or 10 cubic centimeter. Again, ensure that there is no parallax. Sometimes that particular solid may be soluble in water, then this experiment won't work. Then you use some other liquid. It's not necessary to use water, you see. All that we are using is the concept of displacement. We don't have to use water. We can use alcohol, we can use spirit, we can use glycerin, we can use whatever. This is called the displacement method to measure volume. Okay. Now, let us do some simple questions. There's an ICSE board question. In an instrument, there are 25 divisions on the vernier now. This is a different kind of vernier. Usually 10 divisions of vernier coincide with 9 divisions of main scale. But here 25 divisions of vernier coincide with 24 divisions of main scale. Great. At least we have that condition satisfied that n VSD is equal to n minus 1 MSD. That condition is satisfied. Then we can use this formula that the least count is value of one main scale division divided by number of divisions on the vernier. Now, furthermore, it says 1 centimeter of main scale is divided into 20 equal parts, not 10 equal parts. That means the smallest division of the main scale is 1 mm divided by 2, right? So 0.5 mm. So it is 1 by 20 centimeter is the value of one main scale division, and the number of divisions on the vernier is 25. That gives me 1 by 500 centimeter or 0.002 centimeter, right? The least count of a vernier calipers, it is also called vernier calipers, by the way. The least count of a vernier calipers is 0.01 centimeter now, and there is a zero error of minus 0.02 centimeter. While measuring the length of a rod, the main scale reading is 4.8 centimeter, and the sixth division on the vernier is in line with A marking on the main scale. What is the length? So first, let us find out the observed length, right? And then we separately calculate the error. Then we use the formula that the correct length is the observed length minus the zero error along with the appropriate sign, right? So observed reading is main scale reading plus the vernier scale reading. And the vernier scale reading is the least count multiplied by P, where Pth division of the vernier coincides with any division of the main scale, right? So main scale reading is given to be 4.8 centimeter. Least count is 0.01 centimeter, and the sixth one is coinciding. So all of that gives us 4.86. Now, what about the zero error? The zero error is given to us. The correct reading is observed minus the zero error with the sign. Observed is 4.86 minus the zero error, which is minus 0.02. Never miss this sign of the zero error. So you can see that the observed reading is less than the correct reading. Correct reading is 4.88. Observed is 4.86. Why? Because there was a negative zero error. If there was a positive error, then the correct length would be less than the observed length. All right. Let us do this question on reading of a screw gauge. The pitch of the screw is 1 millimeter. Find the least count and the reading as depicted below. Now you can see here how many divisions are there on the circular: 0, 5, 10, 15, and back it is coming 85, 90, 95. That means the 100th division coincides with 0. So that means there are 100 divisions on the circular scale. Then the least count is simply pitch divided by number of divisions, right? Pitch divided by number of divisions in the circular scale, and that is pitch is 1 mm and least count is number of divisions on circular scale is 100, so 0.01 mm. In this case, what is the reading? The main scale reading is, this one is 2 mm, so it is 2 mm plus the circular scale reading, And the circular scale reading is the least count into P, where the pth division of the circular scale is in line with the baseline of the main. So in this case, the P is, you can see 95, 96, 97. 97th one is coinciding. So zero point zero 0.01 into 97 gives us 2.97 millimeter as the answer for this particular reading. There was no zero error. Okay, I hope it is clear. Let us do a question on measurement of volume. In measuring the volume of a piece of cork, it is observed that the initial level of water, piece of cork, it is lighter than water. The initial level of water was 30.2 ml. On immersing an iron piece, which is heavier than water, the level rises to 37.5 ml. And on further immersing the iron piece along with the cork tied together, the level rises to 40.3. What is the volume of the iron piece and what is the volume of the cork piece? Right. Very simple question. Volume of the iron piece is basically the amount by which the water level went up upon immersing only the iron piece. So it was 30.2, went up to 37.5. So the difference of the two is the volume of the iron piece. Now you tie a cork piece and immerse the iron and cork together, it goes up to 40.3. So the difference between 40.3 and 37.5, that was the reading when the iron piece only was inside. That is the volume of the cork. So we'll now talk about measurement of time and measurement of mass in the last module of this particular chapter.